Hello, everyone. My name is Chidowere Jumbo, your presenter. We are going to look at voltage drops and its implication in most of our electrical system network and power systems. It is very, very important and essential for us to understand voltage drop, the negative consequence of it, its negative implication, and the negative impact it has on our appliances, more especially the cable conductor. We are going to start by defining what voltage drop is. Then we will now look at the formula for calculating voltage drop, and then we'll look at the impact, negative impact of voltage drop. Then we'll look at key factors that voltage drop depends. Factors that are likely to improve voltage drop or mar it. So voltage drop is defined as the decrease or a reduction in electric potential in a conductor as a result of what? Resistance. What it means is that resistance is a very big function of voltage drop because it's as a result of resistance that voltage drops occurs. So voltage drop can be related to water that is flowing through a pipe. As the water is flowing, what it means is that the water encounters some friction that prohibit it from running very, very fast. And the negative effect of it will be the pressure of the water will be very, very low because it's encountering friction, it's not flowing freely. And that is how electric current is. As electric current is flowing through a conductor, it encounters resistance, which will not allow it to flow freely. And that is why we say, by definition, that voltage drop is the decrease or reduction in electric potential in a conductor or between 2 points. And those 2 points are the source and the load. And voltage drop is the reason why you see some people living near the transformer because they are almost living within the box source. They normally have their supply okay, have their power okay, have their fridges, have their ACs, everything will be working. But you find out that as you now travel along the conductor, you find out that people at the other end now, probably they are not receiving a very good supply. They might be encountering low voltage because of long distance transmissions. So along the conductor, there will be a breakdown and losing of voltages, which result into power losses in the system. So having known that voltage drop is given as V is equal to IR, we have two equations we can use to calculate voltage drop. We use V is equal to IR. We use R is equal to resistivity times length divided by area. Resistivity could be represented with rho, which is a Greek letter, RHO. So now let's put down the two equations we can use to calculate voltage drop. We have that 1, V is equal to IR. We can call this equation I. Then we have again that R is equal to resistivity. This means rho. It's a Greek letter known as rho. So we normally use this symbol to represent resistivity so that R is equal to resistivity L divided by A. Now, let's identify all these terms so that V is voltage drop, which is equal to the current that is flowing through the conductor, and then R, which is the resistance of the conductor. And of course, you know that R is measured in ohms, I is measured in ampere, V is in volt. Then the second equation again is R now is equal to product of resistivity multiplied by length divided by area. So these two equations can be used to calculate voltage drop. When we come to that, we'll now know how to apply the basic application. Next thing we are going to look at now is the negative impact of voltage drop. One, dimming of light. Most of the light you normally see dimmed, or in your house you have a very low supply, or maybe your bulb is not glowing very well, is as a result of voltage drop. You can see the negative impact of it. It brings about the dimming of our light. It won't glow the way it's supposed to glow. Two, low performance of electric motors. Low performance of electric motors. So voltage drop brings about low performance of electric motors. Remember, electric motors are designed with a specific voltage which can enable them to function adequately and very, very well. So if a circuit that is having a voltage drop, it means the electric motor or electric machine there would not work because the voltage is not adequate. Most of the voltages must have lost during voltage drop processes. So this is another bad effect of voltage drop. The next one is overheating. Overheating of components. Voltage drop brings about overheating of component of devices. At times, you even feel that the cable is very, very hot. That means there is overheating in the very particular cable. So these are the negative impact or consequences of having voltage drop in our network. Then now let's look at the factors on which voltage drop depends, or factors that can either improve them, ameliorate them, or mar them. One, we have thickness or size. Either you call it thickness or size. So it is found out that the more larger or thicker cable conductor is, then less friction. Friction will be less because all the scintillating and moving electrons are there to be accommodated, nothing to disturb them. They are wide spread apart. That means electrons flow quickly. Therefore, the larger the thickness, the less the resistance of that very particular circuit or conductor. The next thing which we are going to look at now is the area. Likewise, area need to be very, very particular, in the particular conductor need to be very, very big, so that if it is big or increased enough, that means it allows the electrons to flow easily than a conductor with a very small area. A conductor with a small area will bring about high resistance in the circuit. Another factor is length. Length is very, very important here to be considered. The more the length of the cable, the higher the resistance. What it means is that if the length is shorter, there is a smaller resistance. If the resistance is if the length is higher or longer, that means you are going to have more of the resistance in the circuit. So we need to be using short runs circuit so that we can run away from voltage drop and higher resistance in the circuit. Okay, thank you very much. You follow me on my Facebook at Chidore Jumbo. We meet in my next edition again. Bye.